This video shows the solution of a question that was asked to me for one of my students. The question is interesting among other things because its solution shows us how the knowledge of the normal distribution can help us to solve some type of problems and also help us to take decisions in some special situations. Let's read first the problem. It says, a global financial institution transfers a large data files every evening from offices around the world to its headquarters. Maybe its headquarters is in another city. Once the files is received, it must be cleaned and partitioned before being stored in the company's data warehouse. Each file is the same size and the times required to transfer, clean, and partition a file are normally distributed, with a mean of 1.5 hours and a standard deviation of 20 minutes. With this information, I would like to answer the following questions. If one file is selected at random, what is the probability that it will take longer than 2 hours? B. What percent of the data files will take between 65 minutes and 105 minutes? And C. If the manager must be present until 85% of the files are transferred, cleaned, and partitioned, how long will the manager need to be there? So let's solve first the question A. Let's type first the information we have. First we have that the mean is 1.5 hours. So I'm going to type the mean in minutes. It will be 90 minutes, 1.5 hours. And the standard deviation equal 20 minutes. The information is here. So equal 20 minutes, the standard deviation. So I decided to use minutes as the unit. So I can also use hours. So if I use hours, both mean and sigma need to be in the same units. Okay, so and now the question is, what is the probability that it will take longer than 2 hours? What is the probability that the time will be more than 2 hours? And 2 hours in minutes, it will be 120 minutes. So 2 hours equal 120 minutes, and then for that reason, I can type the information of the question in math words in this way. What is the probability that the variable x will be more than 120 minutes? Let's type this. Probability that the variable will be more or greater than 120 minutes. Now that I have this, I can use the 3 steps that I use to solve a problem like this. Yeah? So it's a problem, if I want to use a table, a normal distribution table, I divide the solution of the problem in 3 parts. And the first part, remember, is to find the standard deviation. Each of the value in the problem is below or above the mean. And I'm going to tell you now that it will be, this is the same of finding the z value. So I will be finding the z value of the only value that appears in the problem, 120. So I use the formula of the z value. Remember, z equal x minus mu divided by sigma. And the value of x that I have now is 120. And this is the only value that I have so far. So 120 minus mean, and the mean is 90 minutes, divided by sigma, that is 20 minutes. So this equation is just 120 minus 90 divided by 20. I do this in my calculator, and the answer is 1.5. So now we have 1.5. Look at that, the answer is without units. This is 120 minutes. This 90 is 90 minutes. So the numerator is in minutes. This is 20 minutes, so the units cancel. So this is that is the reason why it's a good idea to use always the same unit for the mean and the standard deviation. That finishes the first step in the solution of the problem. So we have so far this, and the question was, what is the probability that the time will be greater than 120? But we have transformed these questions in what is the probability that the variable z will be greater than 1.5. So the questions is equivalent to these questions. So the only that we need to do is use now, from now on, this 1.5 instead of this 120. So what is the second step of the solution? So use a standard normal distribution table to find areas. So I take out my table for the normal distribution and find what is the area when z equal 1.5. So I look down from z until z equal 1.5. And it's better if I zoom in this, so will be 1.5 here, will be 0.4332. So the area corresponding to 1.5 equals 0.4332. And this is the second step of the problem. Now that I have this, obviously, if I have more values in the questions, so I will be finding more areas. Now that I have this, let's see what happened in the third step. The third step is when I'm going to find the probabilities. It's a good idea to make a sketch. When I make the sketch, what I have is that this 1.5, obviously, the normal distribution is like this, the bell-shaped curve, and the 0 is in the middle. This is the standard normal distribution when the mean is 0 and the standard deviation 1. Okay, so because the z value that I have is 1.5, this will be here 1.5. The number will be at the right, between 1 and 2. I don't need to be first side. This doesn't need to be a wonderful graph, just to have some idea of the question in the graph. And if you notice, the question is what is the probability that z greater than 1.5? So what is the probability that z takes the value at the right of 1.5? And these are the values at the right of 1.5. And the areas above these values will be the question that I'm looking for. So this will be if I find this area, I will be finding the solution of the questions. So this 0.4332, remember, the table that I have only gives me the area between the z value and 0. So the area that I have found here is not this one. So the area that I have here will be this one, between 1.5 and 0. So the question is this: what is the probability that z greater than 1.5? So this is the question. But the answer that the table gives me is the area between the number and the 0 and the mean, so that is 0. So for that reason, in this case, so this 0.4332 is all this area. This is 0.4332. But I'm not looking for this area. I'm looking for that. But now that I have this information, now it will be easy to know what is this area. Because I know that this is a completely symmetric curve. So this part from here, from 0 to the right, the area will be 0.5, if half of the 100%. So this green area plus this blue area will give me 0.5. So the probability that x greater than 120, that it was the question, I have transformed this question in the probability that z greater than 1.5. This will be equal to 0.5 minus this area. So if all the half of the curve I subtract the 0.4332, I will obtaining the area in the question. So it will be 0.5 minus 0.4332. So I use my calculator and I find the answer. The answer is 0.0668. And this is equivalent to 6.68%. And this answers the first question. The probability that the time to transfer, clean, and partition the file to be greater than 120 minutes is 6.68% or 0.0668. So now focus in the second question. So remember, what percent of the data file will take between 60 minutes and 105 minutes? And this is the same to say what is the probability. So this percent is actually the probability. What is the probability that the data file takes between 60 minutes and 105 minutes? So the question written in math word will be, what is the probability that the random variable x, this is the time to transfer and clean the file, is greater than 60 and smaller than 105. This is the same as saying that is between 65 and 105 minutes. Okay, so what is the first step of the problems? Find the number of standard deviations. Each of the values in the problem is below or above the mean. In other words, find the z-score. And the z-score of 65 and also the z-score of 105. Now we have two values to find the z-score. So the z-score, use the formula z equal x minus mu divided by sigma. We know that mu in this problem is 90 and sigma was given as 20 minutes. So for 65, just make a substitution here, 65 minus 90 divided by 20. 65 minus 90 divided by 20. If you use your calculator, the answer is minus 1.25, and we get the first z value. Now find the z value of the second value of the 105. So if you use x equal 105 in the same equation, the answer for z will be z equal 105 minus 90 divided by sigma. So the same as the previous value, but now is 105 the x value. And that gives me the answer of 0.75, 0.75. And that concludes the first step for answering the question. Obviously, the question original probability that x is between 65 and 105 have changed now for the probability that the variable z now will be between negative 1.25 and 0.25. What is the second step of the problem? Find the areas, using the normal distribution table, and find the area corresponding to each of the values, of the z values. For example, here the value is 1.25. That's actually negative 1.25. But if you see a normal distribution table, there are no negative numbers here. But this is completely symmetric. For finding the area corresponding to negative 1.25, that is at the left of 0. So it's exactly the same that if you look the area for 1.25, that is at the right. So it will be the same area. So for finding the area of negative 1.25, what I'm going to do is find the area of 1.25. Let's go to 1.2. I prefer to zoom in this part. So let's see 1.2, but it will be 1.25. Go to until when the second decimal is 5. You see in the first column of the table, you're going to see the second decimal. So 1.25 will be this area, 0.3944. So the area corresponding to the z value negative 1.25. I'm going to type this here, so it will be equal 0.3944. This has been rounded to 4 decimals in most of the tables. Yeah, so obviously the real answer will have more decimals, but we are answering this with only 4 decimals, so we are rounding the answer to 4 decimals. Okay, now we need to compute the area corresponding to 0.75. I'm going to take note of this, the area of 0.75. And then go to the table until 0.7 and then 5. Let's zoom in this. So it will be 0.75. The answer is 0.2734. And I'm going to type here the area 0.2734. And I have found the area corresponding of each of the values in the questions. Now that I have these areas, I can go to the step number 3. And the step number 3 is finding the actual probability. So the answer is actually answering the questions. So it's a good idea to make a sketch of the value. So I'm going to sketch the normal distribution with a negative value 1.25, and this area is this is negative, must be at the left of 0. So I'm going to make the sketch here, and this will be the normal distributions, the negative 1.25 at the left, and the area that this table gives me is the area between the number and 0, always between the number and 0. So this is the area that I got so far with this 0.3944. So this area is 0.3944. Now the 0.75 will be at the right, will be like here, yeah, 0.75. So I'm gonna press here 0.75, and then the area that's gonna give me this 0.75, this 0.2734 will be an area at the right. So will be an area like this, 0.2734. So I notice that if I want to know all the area between negatives 1.25 and 0.75, from here to here, I will need to add all the two areas, both areas. Yeah? So the probability that the variable x will be between 65 and 120, I have transformed this in the probability that the variable z will be between negative 1.25 and 0.75. But this is equal to 0.3944 plus 0.2734. I add together all these two numbers, and the answer is 0.6678. And that answers the second question. The probability that the time will be between these two numbers is 0.6678 or 66.78%. Let's answer now the last question. If the manager must be present until 85% of the files transferred, cleaned, and partitioned, how long will the manager need to be there? So I will be answering the question in this way. So I will be answering how long must the manager stay every evening to be sure that he or she is present during the transfer, cleaning, and partition of the 85% of the files. So I know there is a variation in the data, so sometimes the work is made in a shorter time. Yeah, that's true. Okay, so what I'm going to answer is what is the probability that the time, so I'm not sorry that the probability that the time is less than a number that I don't know is equal to 0.85. So I want to know what is this x. What is this value of the time, such that the probability that the time is less than this number is 85%. So I have something like this. I have a normal distribution, And this normal distribution have a 90 in the middle because the mean is 90. And I want to know what will be the value x that has 85% at the left. So that have this area at the left. So I want to find what is this x that have this 85% here. So let's find this x. Obviously, it will be easier if I find a z instead of the x. I go into the normal distribution, but the normal standard distribution, if I go to the normal standard distribution and find this z. So it did say if I find this z, and then I can find the x because there is an equation that relates the z score with x. And I know that this is the z equal x minus mu divided by sigma. So if I know z, I will know this, and I know also sigma and mu. I will be using this equation and I can find x. But if I find this z, I will need to use the table, the normal distribution table, yeah? So remember this. And then I need to find this z here that has 85% at the left. The problem with the table I have is that the area that they have is the area between z and 0. So, and I don't have the area, the area, the 85% that I have is between z and minus infinite. So to know that, I will be, to actually use the table, I will be getting rid of this area here. So it will be, sorry, I will be thinking in just this part, in the 35%, instead of be thinking the whole 85%, I will be thinking in this 35%. So remember they have 0.5 plus 0.35, this gives me the 85%. But I'm going to get rid of this 0.5. I want to be thinking in this 35%. I'm going to do this because my table have just the areas between z and 0. So I need to find here in these areas what is the one that is 35%. And the area that is 35%. So it will be easy because you see the smallest area is 0, and then you continue, and the areas are getting greater and greater until, so you can go in order and then find what is the 0.35, or at least the closest number that is close, the closest number to 0.35. And I found this. Let's zoom in this. So this is 0.3508. So this is the area. So these are the z values in the column at the left. What we have is the z value, but we are using the areas now. The information that we have, this 0.85, in this case 35%, is an area, is not a value of z. So for that reason, I'm going to look for this here. So 0.35 and 0.35 will be this is the closest number to 0.35. This is another close number, but definitely this is closest, 0.3508. So for that reason, 0.3508 correspond to the value z of 1.04. Look at it, in the first column appears the second decimal of the z value. So this 0.3508 as area correspond to this 1.0, and this is the second decimal, 4. 1.04 is the value of z. So I have z equal 1.04, mu equal 90, and sigma equal 20. Let's make a substitution in the equation, and I have 1.04 equal x minus 90 over 20. Okay, so that means that I can solve this equation, and I found the value of x. So the only thing that I need to do is multiply by 20 both sides of the equation. So 20 is going to be cancelled here. It's going to be appears here multiplying. And then add both sides 90. And when I add 90 here, this 90 cancel and appears 90 at the other. So first the multiplication and then the addition. So it will be x equal or 1.04 times 20 plus 90. So this 20 is now multiplying at the other side, and this 90 that is negative here appears positive at the other side. I do this in my calculator, and I found that the answer is 110.8 minutes. So now I can answer the questions. The manager must be at most 110.8 minutes every evening to be sure that he or she will be present in 85% of the transfers. And that concludes the explanation of this problem. In others video, I will be solving the same problem, or I will be showing how to solve these problems in Excel, for example, using a computer.